All right. Hello, team. So it's been a while since I put anything out. Last time I put out a slew of videos. And so hopefully you've been playing around in Cameo, Marplot, and Aloha, maybe some Wiser. But I wanted to put out a short video just kind of going over the PID quiz because I want to make sure everyone kind of understands the workflow behind it. So I had a discussion with one of the members, and it was question 3 that's the one that most people that missed a question missed. And that team member said, I gotta remember the process. And I guess probably I'm very process oriented. I wasn't until I really kind of went to the refinery. I kind of was, I guess, in the military, but I would say the fire service is very task oriented, if you will, and that's how the Army was for me. 10 years in the Army, everything was task based, and the fire service can be that way as well. But I think the fire service is a little better at explaining the why behind the process, or the task, I should say. And so when we do one of our tasks, yes, it's geared towards an end result. There's steps in the task that you have to do. But if you understand why you're doing those steps in that task, I think that, I guess for me, is what would define a process. And when I went to the refinery, my job was a process operator. And, if you don't know what that is, that's working a mill at a mine, that's making beer at a distillery, that's operating a refinery. And so when you kind of look at what we do in emergency services, really we have a lot of little processes, and we don't formalize a lot of those. We kind of formalize the big process, and I would say one of our process controls there is the incident command system and all that. But on a lower scale, we have all these little processes, and when you get all these processes, you basically put them in a toolbox, and that's kind of where they sit. And then depending on the situation, we just pull out the processes we need, apply it to that situation, and I would say that's what emergency response is all about. So I'm not going to, like I said, I'm not going to write down the PID and how you use it, but I'm going to show you my process. And we'll go through the quiz, and then, because that really kind of lays out some of my process. So the question number 1 was, with a reading of 200 part per million and a belief that the chemical of concern is butyl mercaptan, what would the estimated concentration be using a multi-ray? So this one was pretty straightforward. If you look at butyl mercaptan, and of course in our multi-ray we have a 10.6 lamp, the correction factor is 0.52. And so I would take 0.52 and multiply it by 200. And there's a little firefighter math there, but by far the best answer is 100 part per million, right? So I'd say that one was a pretty, now I'm in edit mode, so I'm editing my quiz when I don't want to. I would say that question was pretty straightforward. The second question was, when using an instrument for a suspected Tobin call, what should the technician choose for an appropriate instrument? Well, if you notice, Tobin is in green font. So I said in the video, and it's in the Ray Systems Technical Bulletin, you need an instrument with a bigger lamp. And the Multi-Ray Plus and the Area Ray both have the small lamps in them. So the correct choice here would be the mini ray, because it's got that big, almost 3/8 of an inch lamp. All right, so on to question 3. Question 3 says, what would you expect as a reading on a multi-ray PID with a propane environment? I'm seeing my grammar mistakes now. In a propane environment when the LEL detector is reading 8%. If you recall to the video, I never talked about the relationship between VOCs and LEL. And there's a couple reasons. You can absolutely take a VOC reading, and then if you understand the chemicals LEL, you can correlate those two using the formula, that 10,000 part per million equals 1%. And then, obviously you got to take into account that the percentage of LEL, and if you ratio it out, you can say, hey, you're 10% of the LEL or whatever, right? I didn't talk about it because honestly, I don't see a lot of value in it. All right. The biggest reason I don't see any value in it is because we run Wheatstone Bridge LEL detectors, and every multi-ray has it, every area array has it, and that's by far a better instrument to detect LEL with. The other reason I don't see a lot of value in it is you absolutely, without a doubt, have to know the chemical of concern. And in the case of propane, you have to know without a doubt that it's propane, because you have to understand the LEL. Different chemicals have different LELs. And so, again, a lot of times we don't have that luxury. And so not a lot of value there for me. I'm just going to grab a multi-array with an LEL detector. But check this out. None of that matters, because when you look at this question, the multi-array has a 10.6 lamp. And if you go down and look at the IAP of propane, it can't ionize it. So the question is 0 part per million. So what's the process? Well, the first thing you do is look at your ionization potential of your chemical. That is absolutely step one. Now, if you want a more accurate reading in part per million, then step two is go to the correction factors. And while you go to the correction factors in Ray Systems technical note, that's when you would also see if it's in green font. If it's in green font and you're using a multi-ray, well, hey, go grab a mini ray. And that's really all the process is. But it's all about the ionization potential. That is key, right? So if we think we have a chemical and we go downrange and we haven't checked the IAP, we don't know if we're going to get a reading on that PID or not. So you got to look at the IAP first. And, maybe this was a trick question. I don't believe in trick questions. I get accused of making trick questions, but I would tell you all I do is make questions that require more critical thinking. And if you don't, answer the question correctly, but understand why you didn't, it's our last opportunity to learn. So that was question 3. Now, as far as my process, a lot of the times we're not on the end of the response where people say, oh, I think I have a propane leak. Okay, well, that's information, right? A lot of times it's like, oh, we don't know what's in there. And so the majority of the time that we use our PIDs, we're really not even looking at correction factors, because what we're doing is going in there, seeing if we get a hit. If we do, we know something is there. They're ultra-sensitive instruments. And but all we know is, hey, we got one of 600 and some chemicals. The other thing I would tell you we use it for is, hey, if you're only getting a few VOCs, well, then we know it's a low vapor pressure product. If we're getting a lot of VOCs, then we know it's a high vapor pressure product. And I would say that's the biggest, use for our PIDs. We're not really out doing dosimetry and understanding exposure levels with it. We could, and that's always, again, a nice tool to have in the toolbox. But so that was question 3, you guys. You can't ionize propane with our multi-ray. All right, everyone. Thank you. I hope everyone's well. I hope to hear from you in the comments section. I was actually up north last week, and that's why I've been kind of quiet. I went up there to delineate a spill, and if you guys would like to have me talk about that, I could. It's work I love to do. The weather was not very nice, and I could not keep the bridge of my nose warm at all. But Yeah, it was a good time up there. So, yeah, we'll see you in the comments section.